Today we're starting solving systems of equations. Well, actually, it's just called Systems of Equations, the unit. Today we're looking at solving graphically. We'll learn some different ways of solving. Today is graphically, based on what we've learned already in the semester about graphing equations of lines. And now we're looking at where they intersect. Where they intersect is the solution to the system. A system of equations is it's two or more equations that we are asked to solve. Okay, we'll learn some algebraic methods too. That's sort of more what the unit is about, and look at some applications of systems of equations. So really we're going to, in this course, just look at two equations, so a pair, but if you continue on in IB in the higher level, we'll look at systems of three equations. Okay, so let's take a look. Solve the system of equations by graphing using the slope and y-intercept. So we're kind of giving you a hint here. First one's already in slope y-intercept form. Okay, so let me just move this. So we want to plot -1, the y-intercept, and use the slope to find some more points. Remember, do as many points as you can that fills up the paper. Just makes it easier once you get your ruler out. Okay, I'll use this. Oh, okay, gotta try that again. There we go. All right, so there's one line. Let me just fix it a little bit there. And you should have put arrows at the end. Okay, so blue. Okay, and then the next one is not solved for y. So because that's a negative y term, I'm going to bring it to the right to make it positive. You can bring all the other terms to the right, totally up to you. Divide by 2, then put it in slope y-intercept form. So that's going to be 1/2 x plus 4. You can keep it like this, but this, based on what we've already learned, is a little easier. Okay, so our y-intercept is 4 and our slope is 1/2. Well, already we know where they intersect. I just plotted it, right? Because it was on the blue line. Not the hockey blue line, but in any case, so here, graph your line. I'm just going to go a little bit better. And so the solution is where those lines intersect. So you can tell it's right there. So the solution is 2, 5. Okay, so there's your solution. So it's 2, 5. Remember, comma in between and round brackets. So now it says substitute the coordinates into both equations to verify. So my equation 1, how I verify, I like to do a t-chart, keeping the equal sign away, because we don't know for sure, maybe we made a mistake, something like that, whether it's going to work. So my y value is 5, my x value is 2, so I just evaluating the right hand side, 6 minus 1 is 5, so the left side equals the right side. So it works for that one. Next one, I go back to, sorry about the squiggly lines, the original equation, because maybe you made a mistake in solving for y. So this is a good way to check. Use your original form of the equation. My x value is 2, my y value is 5, the right side 0, right? So that's going to be 2 minus 10 plus 8, that's 0, 2. Okay, So it satisfies both equations. So if you had chosen the wrong point or graphed one of the equations wrong and chosen a point on the line, it would have satisfied one of the equations, but not both. So you do need to check both equations if you're verifying. Okay, now we'll do this. This says use x and y intercepts. So remember the x-intercept is when y is 0. So that basically that term goes away. So x is going to equal 6 because this goes to the right. Y-intercept is when x is 0. So that means here x is 0. Bring 6 to the right and divide by -2. So y is going to be -3. Then so I'll do that one first. So 6 and -3. Okay, so basically up 3 to the right 6 or down 3 to the left 6. Just get a couple of points in there. And arrows on the end. Just treat it like a proper there we go. Okay, then maybe I'll do blue for the next one. Okay, so let's do x-intercept is y equals 0. So y equals 0, that's x equals -6. You don't even have to move anything. Y-intercept is when x equals 0. So when we do that, we get 6y equals -6, so y equals -1. You don't need to show all the work, right? You've already done that in the last unit. So x is -6 and y is -1. So basically down 1 to the right 6, so down 1 to the right 6. And then join that up with a line. So they intersect. Okay, let's maybe do blue here. And then you want to find the point of intersection. So kind of estimating here, right? So by graphing, that's why algebraic solutions are going to be better because we'll be more sure about our solution. To me, it looks like about 3 and -1.5. Or 3 and -3/2. Okay, approximately. So let's verify. So let's see here. Again, use the original form. So x is 3 minus 2 times -1.5 minus 6. So that's going to be 3 plus 3 minus 6, which is 0. So left side equals right side, so we're good on that. Then this one was what? X plus 6y equals -6. So x is 3 plus 6 times -1.5. So that's 3 minus 9, which is -6. The right side's -6, so we did a good estimate. It was exactly correct. Okay, but that's the reason why graphically it's a little bit hard when you're doing it by hand if it's in between there, because it might not be a half, it might be an eighth, and that, or a 12th or something like that, and that's hard to see. So this is just what we do for now, and then we'll learn some algebraic methods. Okay, so let's look at some special cases. So graph the following system of equations. So taking a look here, so my y-intercept is 4, and my slope is 2. So I'm going to graph those. You can pause the video anytime, right, when you have to do graphing. Okay, so I'm going to join them up in the same step in a minute. My other one is -5. And notice how it has the same slope. So that should kind of ring a bell to you that, I think I did that right. -5, -3, -1. Yeah. Okay. And then joining those up. So here, I'll deal with that in a sec. Okay, I can extend them out, but take a look at them. They sure look parallel to me, right? And we learned back in the coordinate geometry unit that parallel lines have the same slope. Okay, so I can put, what am I doing? What am I doing? You can put arrows on the end. I wish. Okay, and then same on this one. Okay, so what's special about these lines? They are parallel. How many points lie on both lines? None. What is the solution to this? There's no solutions. Okay. And so sometimes we'll say that's the null set. So you either say the word or this or this empty set. Okay, so no solutions. They'll never intersect. So taking a look at the equations, they have, they have same slopes, different y-intercepts. Okay, that means they're parallel and distinct. They're never going to touch. Next one, let's, we've got it in slope y-intercept form. Let's just put this in slope y-intercept form. And you'll notice they're exactly the same line. If you put them in the same form, then you can tell if they're exactly the same equation. So no matter, so I'll just do a few more points here. Okay, so joining these up. Okay, if you had, say, found the x-intercept, so x-intercept, you would cross out the y, x would be 2. Yep, it is. If you had found the y-intercept, you'd cross out the x, y would be 4. Yep, it is. So if you hadn't converted it, you wouldn't have maybe realized they were the same line. But then when you go to graph it, you'd get the same line. Okay. So what is special about these? They are exactly the same. How many points lie on both? Infinitely many. So what is the solution to the system of equation? Well, how many solutions is infinitely many, and what is the system? A solution, I should say, is the equation. So basically you would copy out whichever form you like. I'm going to use the slope y-intercept form. That's the system, because every point on that line, on this line here, is on both of them. So we call these parallel, I'll put it here, parallel and coincident. So remember that prefix co means together. Incident means on the same, touching each other. Okay, so given a system of two linear equations, how can you determine whether there will be no solution, one solution, or infinitely many? So basically, for no solutions and infinitely many, they have to be So parallel, so same slope. Same slope. And for no solution, they would be different y-intercepts. So this would be same slope and same y-intercept. And this just have to be different slope. If it has the same y-intercept, then that's where they intersect, right? Okay, so the next one, for 2x minus 3y equals 6, determine another equation so that the system has no solutions. One solution that kind of got squished in there, or infinitely many. So here, if there are infinitely many, then you could just copy out the same equation. But it does say another equation, so what you could do is multiply it by 2, for example. So 4x minus 6y equals 12. That's another equation that when you solve it with the original, you get infinitely many because they are exactly the same equation. No solution would be the same coefficients of x and y, because that's what determines the slope, and then change the constant term, because that will end up changing the y-intercept. Okay, so that's what you want to change. And one solution, just change a coefficient. So make this x minus 3y equals 6. Change either. Just be careful if you change both, make sure you don't do it as a multiple of these, because then it will reduce to the same slope. Okay, so now we're going to look at solving a system algebraically. So here are the steps in a TI calculator, which I'll go through with you. It says solve the following nonlinear by using a graphing tool. So we will learn some algebraic methods of doing this next semester, but for right now we're using a graphing calculator. So you want to get this out. Okay, you want to clear your calculator, go to y equals, and there's no trig in this, so you don't care about mode. You just start entering, so x to the exponent 3, cursor out of that, plus 2x squared minus 3x minus 13. And then the other one, 2x squared plus 4x minus 7. Okay, now I always suggest starting with what we call a standard screen. So go to Zoom and down to standard, or just press 6. Enter on that, okay, and it will graph. It already started graphing, I noticed here. Okay. All right, so you can see it's kind of the zigzag one is the cubic, and the red one here, the U-shaped one, is the quadratic. It says sketch them and highlight the solutions. So you might want to, well, you're going to have to extend the grid so that we can see the points of intersection. We can see these two. Can't see the bottom of this graph. So in your window now, that's where you're going to change your y's. You don't care about the x's, you can see them. So y, maybe I'll go down to negative 20. And then cursor to y max, maybe I'll go to positive 20. Okay, so now you can see your graphs a little bit better. So when you're supposed to do a sketch here. So let's see. I'm going to move this down a little bit. So a little bit hard on the tablet. Okay, so let's see. So it's not perfect, but it's close enough. So I'll do the other one in blue, and I zigzag. Okay, so I kind of go up like this, down, and then kind of like that. I'll go back to my red, like that, go out more. So there's a point of intersection, there's a point of intersection, there's a point of intersection. Okay, so highlighting the solutions, all right, and then it says check by substitution. So now we actually have to, in our calculator, find them. So how do you do that? Well, the most common key that you're going to use a lot of times in your calculator is your trace key or your second trace, which is calculate. And so we're going to find the intersection points of these sorry, I went too far. So second trace, intersect, or you can just press 5. Okay, now you'll see it flashing and it says first curve. So enter on that, and then it flashes on the second one. So enter on that, and then guess, enter on that. So it's really just enter, enter, enter. It goes to the closest intersection point to where your cursor was. So that is x equals -1, y equals -9. So -1, -9. Then second trace, intersect again, number 5. Now you're going to need to cursor, before you do anything, closer to the other one. So now press enter on first curve, enter on second curve, enter on guess, and it's -2, -7. And then do it again. And again, you got a cursor. Now you can flip to the other one. It's faster, you can put in, but now we're there. Enter, enter, enter. And that's 3 and 23. Okay, so it says check each solution by substitution. So I'm going to start with the positive one. Okay, so and with equation 1. So that's y equals x cubed plus 2x squared minus 3x minus 13. Okay, and I'm going to check it for this one. I'm not going to go through all the checks, just do one of them. So your y value is 23, your x is 3 cubed plus 2 times 3 squared minus 3 times 3 minus 13. Okay, so we're done with the left side, nothing to do on that. And then, so that's 27. You can put it all into your calculator if you want, or practice using your brain. Okay, so 27 plus 18 minus 9, that's going to be 36, minus 13 is 23. So left side equals right side. And then for the second equation, that's y equals, what was it again? 2x squared plus 4x minus 7. Okay, so y value is 23. 2 times 3 squared plus 4 times 3 minus 7. So that's 9 times 2 is 18 plus 12 minus 7. 30, and that's 23. So left side equals right side. Okay, and so you can go through for the other 2 points and make sure that they satisfy as well. And then basically in this part, we're just doing what we just did, verifying certain points. So is -3, -2 the solution to this equation? Justify your answer. So you're going to have to check in both. So first equation, and that's 3x plus y, -11. So 3 times -3 plus -2. So -11's on the right. That's going to be -9 minus 2, which is -11. So yep, that works. And then the second equation, and that's 2 times negative 2, 5 plus 3 times negative 3, so that's going to be negative 4. This is 5 minus 9, which is negative 4. So left side equals right side. Yes. Okay. Yes, it is. Next one, this one, notice how it says the solution is this value. So now determine the values of p and q. So this is your x and this is your y. So in your first equation, you've got 5x plus py plus 23 equals 0. Actually, we know it's a solution, so you don't need a t-chart. We know it should be equal to each other. So where x goes, I put negative 3. Where y goes, I put 4. So that's negative 15 plus 4p plus 23. And what's that? 4p, 18 plus 8. 4p equals negative 8, p equals negative 2. And then y, in the next equation, my y is 4. My x is negative 3. Okay, so 4 equals negative 3q plus 16 over 7. So I like to multiply and get rid of the denominator first, but you can rearrange if you want to. Okay, so now I have 28 equals negative 21q plus 16. Subtract, I get 12 equals negative 21q. And so q, excuse me, equals 12 over negative 21, which reduces to negative. We don't want to keep a negative in the denominator. 3 goes into 12 4 times, into 21 7 times. Okay, so just summarize here, p is negative 2, q is negative 4/7. You don't put those in an ordered pair because the equations are in terms of x and y. These are just the values of p that make sure that these equations have the solution negative 3/4. And that's it.